You spend months cleaning data and optimizing weights. Your model is accurate, but when presenting findings to leadership, the transmission degrades. Stakeholders interpret output differently. A model's value depends on a human decision-maker's ability to decode its implications. Without that successful decoding, the technical work lacks a path to organizational implementation. Human communication functions as a dynamic, lossy transmission protocol. In this system, meaning is encoded into a shared framework of vocabulary, symbols, and physical behaviors. Oliver Wendell Holmes observed that ideas grow when they are transplanted into another mind. Protecting data from becoming noise requires two specific interventions: optimizing the communication channel and performing rigorous cognitive feature extraction. This also requires calibrating for the hidden cultural operating systems running in the background of your audience's cognition. Mastering this transmission system allows a technical professional to translate computational insight into actual leverage. We analyze this process through 7 elements of communication: sender, message, encoding, channel, receiver, decoding, and feedback. The primary vulnerabilities are the encoding and decoding nodes. Noise is the physical, semantic, or psychological factors that distort the signal between these nodes. Defensive communication begins with optimizing the channel node. The medium dictates how much information survives the jump from sender to receiver. Daft and Langel's media richness theory provides the framework for this selection. The theory dictates that the richness of the medium must match the ambiguity of the message. Attempting to align stakeholders on a complex project pivot via email often fails because the medium lacks the bandwidth to carry the necessary nuance. This is further refined by media synchronicity theory, which separates interactions into conveyance and convergence. Conveyance, sharing raw information, functions well with low synchronicity. Convergence, the building of shared understanding, demands high synchronicity and immediate feedback. Selecting an uncalibrated channel creates a structural gap in the communication loop before the receiver even encounters the data. Let's isolate the receiver endpoint and analyze how auditory information is processed. Hearing is a passive physiological process, the raw input of sound waves being converted into neural signals. Listening is the active cognitive counterpart, filtering and organizing that raw input into a structured data matrix. This process operates at 5 levels. At level 1, ignoring, the receiver makes no effort to process the input. Level 2 is pretending. This is performative listening, where physical cues are provided without any internal processing of the data. Level 3, selective listening, involves a biased interpretation, where the receiver only captures data that aligns with their pre-existing priors. Level 4, attentive listening, captures the words but remains centered on the receiver's own perspective rather than the speaker's intent. High-fidelity extraction requires level 5, empathic or active listening. This demands full cognitive dedication to decode the words, the intent, and the context simultaneously. In technical fields, poor listening is the equivalent of training a model on misaligned data. Operating below level 5 during complex problem-solving results in an internal model of the project that is misaligned with reality. Sustaining level 5 listening requires physical calibration to manage energy and focus. The solar model provides a specific physical framework for this state. The S and O, sit squarely, and maintain an open posture, physically prime the body for reception. The L, A, and R, lean in, relax, and maintain appropriate eye contact to further stabilize your focus. These actions focus attention while providing the sender with feedback. This physical orientation functions as an active mechanism for lowering transmission barriers and improving the quality of the incoming signal. Cultural context represents the most complex source of semantic noise. It operates below conscious awareness, acting as a hidden algorithm that governs how an audience interprets a message. The cultural iceberg model illustrates this. Above the surface is the visible culture, language and dress. Below the waterline is the hidden culture, concepts of time, authority, and spatial norms. These hidden structures dictate the rules for how information is decoded. Every interaction carries 2 layers: the content dimension, the raw data, and the relational dimension, the status of trust and power. Hofstede's cultural dimensions provide an analytical framework for mapping these relational rules. Variables such as power distance and uncertainty avoidance significantly impact workplace communication. Ignoring these variables triggers relational friction that obscures the factual content of the message. We can contrast these frameworks by looking at low-context and high-context communication styles. Low-context cultures, like Germany or the US, are explicit and literal. Presenting unvarnished, direct data to a high-context stakeholder without building relational capital can trigger defensive responses that prevent the data from being accepted. A fully optimized communication loop requires matching synchronicity, applying empathic listening, and filtering for cultural noise. Multicultural technical teams can bridge these gaps by explicitly naming shared ground rules for feedback early in the project. It is also necessary to separate an individual's observed behavior from their assumed intent. Friction in communication style is often a clash of cultural operating systems rather than a sign of negative intent. The Dalai Lama notes that listening is the mechanism by which we learn something new. In an environment defined by artificial intelligence and data, culturally aware communication is the bridge that connects